and you mess up less as you get older. One of the greatest lies that our society has inflicted upon people is that you need to be perfect, because you don't. You need to be a worker and you need to try. Everything else will take care of itself. And if you really do stink at something so bad that you do it over and over and over and over again, you still don't get it right, perhaps we should consider another career. You know what I mean? You're not going to be like that with everything. I stink with music. You could ask me to sing that note 3,000 times in a row. And if I had to sing for a living, I'd be really, really skinny. So I wouldn't be able to eat. So we choose a different career. Okay, true or false? Let's go through and check these things out. The square root of 4 plus 9 is equal to square root of 4 plus the square root of 9. What do you think? False is correct. Square root of 4 is 2, square root of 9 is 3, 2 plus 3 is 5, and the square root of 13 is clearly not 5. 1/2 plus 1/3 is 5/6. What do you think? True, very good. 3 squared times 4 squared equals 12 squared. That does work, very good. Okay, and now we're up to number 2. And this is similar to what we did yesterday, okay? I expected yesterday to be awkward, but today I think we should be able to understand it a little bit better. 2-color printing process. M is, well, they buy B, capital B gallons of blue ink each order. K for black. It's the same as yesterday. I just want to really make sure you understand it. And little m is the number of orders of blue, and little n is the number of orders of black. So what is m plus n? Total orders. Very good. What is mb plus nk? Total number of gallons. Very good. And what's the last one? Average gallons per order, average quantity per order. And then we spoke about how the company made twice as many orders for black ink than for blue ink in January. Give interpretations. Well, if they made a greater amount of black ink than for blue ink, then the fraction with the black ink is going to be greater, which is what we're looking for there. Same exact question as we did yesterday. I just really felt that a second day of looking at it might make it better understood. Are we okay? All right. So now we go forward to today's lesson. And let's talk about inequalities and so on and so forth. Now, a squared equals 25 has 2 answers. We tend to only think of 5. But not only does 5 squared equal 25, what else do we know? Negative 5 squared equals 25. And by the way, at Extra Help today, again, we had 2 people mess this up at Extra Help today, and I just want to reinforce. There is a difference between this and this. One of those equals negative 25, and one of them equals positive 25, which is which?
Negative 5 to the second power, and like not in the parentheses is the negative 5.
Right, that means square it, then negate it. The other one means negative 5 times negative 5. So that's just a review moment that's very important. And along those lines, similar kind of thoughts here. If I square both sides, or square root, I'm sorry, both sides, 5 squared is 25, but so is negative 5, hence the 2 solutions. So it's a true statement when a is 5 or a is negative 5. In set notation, we could say negative 5 or 5. Okay? On a number line, we plot the points, negative 5 or 5. Have I done anything with any degree of difficulty so far? No. No, very simple. Okay. Now, set notation is, I call them squiggles, curly brackets, whatever you want to call them. They indicate that you're starting with a set, and everybody should understand we're dealing with a set. And a set is a way of mentioning a collection of things, numbers, whatever, okay? So, from this example, when we say negative 5 and 5 are elements of the set, that just means they belong in there. There's one, that should have went that way. There's one squiggle, there's the other squiggle. I like to look at them as somewhat looking like Alfred Hitchcock's silhouette. I don't know if any of you understand that humor. He was a great director from years ago, and at the end of his movies, he put a silhouette picture of himself. So if you look it up, you'll find it. Now,
My squiggles look better.
just congratulations. You'll notice I don't teach art. Okay?
I don't take art.
It's kind of like a recurve bow, though, isn't it? Kind of, if I just went like, wouldn't that be like a recurve bow? There we go. See, I am all over this stuff, like white on rice. Okay, now, when you list elements in a set, it's important that you list them in increasing order. You don't want to like, let's say the set has 12 things in it, and you go negative, positive, small, big, and you mix them all up. Then the person looking to read the set might not be able to see if all the things are there. So we just go from smallest to biggest every time we write out the thing, okay? Now, sometimes the set is empty. In other words, there are no answers. For example, what if I said this? X squared equals negative 4.
That's cool.
What number squared is negative 4?
Oh, 2.
No, 2 squared is positive 4.
Hey,
Negative 2 squared is positive 4.
Oh, wait.
negative 2 in parentheses.
Oh, we heard the oh wait. That means the little light bulb's going
No,
off.
but that means not in parentheses.
No, there's nothing that times itself. There is no real number that multiplied by itself equals negative 4. Because the only way to make a number negative with multiplying, if there's 2 factors, would be a positive and a negative, which automatically means that they have to have different signs, so it can't be the same number. So, for real number purposes, we're not considering imaginary numbers, we would say the answer to this is that. It's an empty set. You would not put 0.
Not zero, but like the question mark maybe?
No, not a question mark. This is one way to do it, and that's a way to do it. Those are the only 2 ways to do it. If there's no answer, it's what we call the empty set. There is nothing in there. All right. And I use the example of what squared equals negative 25 there. All right, so now I want to think about inequalities. And I know you've done some work with inequalities last year. And we're setting up a couple of days worth of study with inequalities. So we're not going too deep today. Tomorrow we'll deepen it up just a little bit, and we'll come up with some rules for inequalities. But I want to think about something and compare it to this. Do you know what amazes me?
What?
Absolutely amazes me, the internet.
Me.
The internet, besides you guys personally, yes. The internet amazes me. Like, I have a website built into this laptop. This laptop is the source of MrLinquistMath.com.
Yeah.
This website is the source of EmpireStateCAS.com. That's my Central Asian Shepherd website. And soon it will be the source of FliesForFish.com.
Oh.
Now, if someone sitting anywhere in this world Googles Empire State Shepherd, or pardon me, Google Central Asian Shepherds, somehow my laptop has some. I know somebody up by Buffalo who has some. I know somebody down by Georgia who has some. Somehow, out of like thin air, they call it cyberspace. Somehow, out of cyberspace, BAM!
Ooh.
All of the places appear on my laptop, or whoever's Googling it, or Binging it, or Yahooing it, or whatever you're doing to it. Now, then you click on it, it's there. How it connects all of these things in cyberspace, and then it rifles through cyberspace, and it says, like, this one applies and this one doesn't. Like, for instance, I'm sure you have used the Google every now and then. I gotten back a website that you weren't too particularly happy with. Know what I mean?
No.
Right?
Yes.
Right. So, but somehow, almost all the time, whatever you're searching for, relevant websites come up. And then irrelevant ones are pretty much ignored. And it even sorts them in order, like most relevant to least relevant, and it does millions of them,
Aren't you thankful for the person who invented the internet?
which, according to Al Gore, was him. But anyway, it blows my mind that such a thing exists. Does anybody know where cyberspace is?
Everywhere.
Everywhere. Do you like go to a room and open the door and go, "Hi, I'm in cyberspace"? Do you go to the internet? Does anybody like walk into a room and see, "Hi, ha, I found the internet, there it is," and you reach out and touch it?
Yeah.
You are a special young man. No, of course not. I did, however, hear that the cloud lives in a specific place.
Wait, what do you mean?
I heard that, you've heard of the cloud,
Oh.
right? I heard the cloud is actually housed in Iceland. And there is this like hangar kind of thing with billions of servers in it, and billions is an exaggeration, but all of this server and memory in the cloud is an actual backup physical location. But cyberspace clearly is not. Now, not only is there cyberspace floating around all around us, which kind of connects all of these websites, but there's also number space. Like, does anybody know where numbers are? Do numbers live in a particular place?
In your
Yes,
brain.
they do.
What's that?
Of course they do.
Really? Where's the number 4 live?
On paper.
Right there.
But if he's on your paper and he lives there, how could he also be on Allie's paper?
This is a time
No,
traveler.
not on my paper. On paper.
Oh, so you can't think about the number 4 because he's living on paper.
Well, actually, okay, it lives anywhere.
It lives everywhere, okay?
Anywhere and everywhere. So he's in the number equivalent of cyberspace, which is number space. And when you want to solve an equation, remember how when Google wants to find a particular website, they go through and somehow, however Google does it, it searches everything out there and it brings back all the relevant answers?
Yes.
Okay. Well, it's kind of like that when you solve an equation. So for instance, if I solved an equation, let's say this particular equation, ready? 3x minus 1 equals 8. And you have an algorithm for solving it, just like Google has an algorithm for figuring out what websites meet your search criteria. Plus 1, there's your algorithm, die. 3x is 9, divide by 3, x is 3. So all of a sudden, through my algorithm, I go through number space. And I go, I'm going to consider all the numbers that are possible in the world. But out of those numbers, there's only one answer. So if I was to do, if you will, a math search, like a Google search, the only number that would pop up is 3. And when 3 pops up, if it was multiple choice, you know that you would have to choose the choice of 3.
No, but as in, it's what, like, is it 8th grader? So it's supposed to be like.
But I didn't say greater, I said equals.
I know. I'm just saying.
Okay, well,
I know.
the point that I'm driving at is this. At this point in time, when you solve an equation, what's really going on in the background is this. You're saying, with an equation now, an equal sign, what's the one and only number in the world, the one and the only one number in the entire cyberspace, math space, number lane that exists, for which 3 times that number minus 1 is 8. And the only number for which that's true is 3. So out of all the possible numbers in number space, like cyberspace, the only one that will possibly work is 3. If you try any other number, it won't work. For example, if I try 4, 3 times 4 is 12, minus 1 is 11, it does not work. If I try negative 2, that's negative 6 minus 1 is negative 7. That does not work. I could try 1,000,000, that's 2,999,999. That doesn't work. But inequalities are very different. When you read this inequality, what it's saying to you is, find all the numbers in number space so that 3 times that number minus 1 is not equal to 8, but is what? Less than 8. Now, that same algorithm, algorithm just means a technique or a strategy. The same algorithm that we used, the same practice we used to find out that x was equal to 3 in an equation, we're going to use the same exact strategies, algorithm, technique to solve this. First, I'm going to do plus 1, die. 3x is less than 9. Then I'm going to divide by 3, and I get x is less than 3. Now, here's the problem. There are an infinite amount of answers to this question. Any number that's less than 3 will work. Somebody give me an answer less than 3.
2.
Negative 700.
Negative 700. Negative 700 times 3 is negative 2100. Negative 2101, that's clearly less than 8. That works. Somebody else. Negative 1. That's 3 times negative 1 is negative 3, minus 1 more is negative 4. That's clearly less than 8.
Negative 2.9 repeated.
Yes, that's less than 8. Good.
Did I?
0. Oh, that's my favorite. 0 minus 1 is less than 8. 0 is my favorite because it's so easy to work with. Okay, any number that's less than 3 will work. So here's the big difference. Going back to the question I posed originally, 3x minus 1 equals 8, and we came up with x equals 3. When I had an answer space, all I needed to write on that answer space was 3. And my answer was correct. The problem is, with this inequality, again, inequality because of the less than symbol, there's an infinite number of answers. You have answers like Alex mentioned. You have answers that are more normal answers like you guys mentioned. And of course, we have the wise people with negative 700. There's so many answers that if I tried to put them on an answer space, I could never put them all. I could spend the rest of my life filling in just the answers to that one question, and I could never fill them all in. Because like if I thought negative 2.5 was the answer, then I could do negative 2.51. And if I thought that was the last answer, I could do negative 2.511. And if I thought that was the answer, I could go negative 2.5111. And then if I think I run out of ones, I'll just go to twos. And then when I run out of fives, I'll run to sixes. So there's an infinite amount of answers. And what that means is this. I need, with inequalities, to express my answer very clearly. In set notation, I would write the squiggle, X, and a slash. Now that slash is math language, or math-ese, if you will, for such that.
What?
Such that.
Oh.
It's saying X such that. That means that now I'm going to tell you about the X's. The answer is any number, X, such that the number is less than 3. Is 3 an answer to this question? No. How do you know 3 is not an answer to this question? Right, if it had or equal to, it would work. If we just try it out, 3 times 3 is 9, 9 minus 1 is 8. Is 8 less than 8? No. So any number less than 3, negative 2, pardon me, 2.9999999999999999999, that works. You could add another 9, that works. You keep adding 9s until the world blows up and ends. That'll still work. But the actual 3 does not work because it's not less. You try the next one. Go ahead. Go ahead.
Would it be wrong if you put less than and equal to 2?
No, that would be wrong because there are answers between 2 and 3 that you would be leaving out.
Oh.
If I said the answer had to be an integer, then you could do that. Integer means whole number values, positive, negative. Okay. So we said before, listen, Miss Bob and Weave, we said the answer, that's a boxing term. The answer we said before, we used the same strategies, the same algorithm. So what's my first step, everybody?
Subtract 4.
Subtract 4, very good. Die, 2n greater than or equal to 12. What do I do next?
Ooh, divide by 2.
Divide by 2. N is greater than or equal to 6. If I wanted to graph it, not that we've done a lot of graphing with this so far, but here's 6. Do I fill the circle in?
No.
Remember this from last year?
Yeah.
Yeah, I do fill the circle in because it's allowed to equal
Oh,
it. One quick, easy, cheesy way to remember this is just take the extra ink and use it to fill in the circle. And then as long as the letter's on the left, the arrow always goes in the same direction that the inequality is pointing. So n is greater than or equal to 6. Yes?
We didn't have to do that. N/n greater.
Oh, yeah, I'm going to mention both of them. Most of the time, people would just write on their answer space, n is greater than or equal to 6, and that's fine. We would take credit for that. My problem is that they may give you choices, and the choices would probably look more like this. So I want you to be able to interpret that choice. You don't necessarily, it's like this. If someone speaks Spanish, as long as they go slow enough, I can pretty much figure out what they're saying. Yo hablo un poquito español, muy poquito. However, if they start either going too fast, or if they either go too fast, or if they use too many words, I get lost. So likewise, I can say it, or I'm sorry, I can hear it if I go pieces at a time and I can process it and I know what it is. So you should be able to process that. You don't necessarily, I don't speak fluent Spanish, but I can comprehend it. So I want you to be able to comprehend that symbol. If need be, you can write it. But the big thing I want you to understand is this. N is greater than or equal to 6. All right, try the next one, and there is a bit of a hitch in the next one.
Great, thank you.
I noticed that, and I asked myself if it's because you hurt your hand or because the wrap's too tight. I don't know the answer. I know I'm not gonna take off a professional rap. So. All right. Go ahead, solve the last one.
Doesn't this look like pizza?
Yes. You like pizza.
Or candy corn? I hate candy corn. I love candy corn.
I know what Emma thinks about it all the time.
Candy corn and pizza? That's the saddest thing I've ever heard. I like candy corn, but if I eat too much of it, then it makes me...
Yes, I agree. A little bit is a wonderful thing. Too much is bleh. I like candy corn when they put it on top of cupcakes with icing. It's rocking. All right. -3, -3. X over -4 is less than 2. And now, obviously, what is the next step? What's the next step? Multiply by -4. Good, Hunter. But now we get into what would be the hitch in the ointment and the last thing we need to talk about with this today before we go more full bore with it tomorrow. Here's what I want you to understand. Do you see how we're multiplying both sides by -4? Everybody watch me, you with me on this? This is very important to catch. We're actually, I like to look at it as we're kind of doing two things at the same time. We're using the 4 and we're also negating. Does that make sense? The 4 and the negating. So die here. This is going to be -8. This is going to be x. But not only, this is very big, so make sure you're paying attention. Not only are you negating this side when you put the negative there, and negating this side, but you're also negating the sign. So it becomes x is greater than -8. Now let me explain why this is so, because it actually makes a lot of sense. Let's say that Maya takes out her Turkish non-recurve bow, and she goes into a competition, and in that competition she has to shoot at 10 targets. And the first time she gets 9 out of 10 targets, bullseye, center spot. So if you negate, if she gets at least 9 out of 10 the first time, and you negate that, she got what? Less than 9 out of 10. Does that make sense?
Yeah.
Right? If in my wallet I have more than $100, if I negate that, what do I have? Less than $100. If I weigh less than 1,000 pounds, and then I negate that, what do I weigh? More than. So the negation of more than is what? Less than. And the negation of less than is more than. So when I used the 4 and the negative sign, I'm not only negating the left side and the right side, but I'm also negating the symbol. So I negated less than, and when I negate less than, it becomes what? More than. And that's why the sign switches. So it's x is greater than -8. Yes?
So is it just every time you get a negative?
Every time, listen carefully, guys. Every time you multiply or divide by a negative, adding, subtracting, don't matter. Multiplying and dividing, always switch the sign. Yes?
What are we doing?
This is the way I said you should do it.
Really? And then it was like, I really got it.
Hey, look.
So 1
Maya, look.
Oh, and you want to put like -4 over 1? That's fine. It works the same. You get the same exact answer. Okay, so tomorrow we'll solve a whole bunch of inequalities. Today we set up, listen, excuse me before you pack up. Today we set up the theory behind it. The idea of all the things out there, the fact that there's an infinite number of answers and you can't fit them all on the blank. Also to multiply and divide by a negative, and you're going to switch the direction of that inequality. All right, so that's what we cover for today. We will go into,
More detail.
yeah, we'll apply it a lot tomorrow. Today was just figuring out that it is and why it is. Tomorrow is to go out and do it.